Hello, everyone, and welcome. Thank you for joining us in this session where we'll be discussing about 800 gig PAM4 signal testing. I'm Aldo Gutierrez, Product Line Manager at Exfo, responsible of the products involved in transceiver compliance testing, including electrical bit error rate testers, optical sampling scopes, clock data recovery source, and optical spectrum analyzers. Joining me today, there is an expert in the testing transceiver field for going through the presentation, Francois Marcotte. Hello, Francois.
Hi, Aldo.
So, Francois Marcotte is a subject matter expert currently working at Exfo in Montreal, Canada. With more than 28 years in the telecom industry, he began his career at Bell Canada. Over the years, Francois has developed deep knowledge on Ethernet, OTN technology, and optical transport. He's also a regular speaker in various seminars in North America. So please don't hesitate to ask questions to Francois or myself. You can put it in the chat, or also you can raise your hand if you have a burning question. We will try to take as many questions as possible during the event. Also, keep in mind that this session lasts 30 minutes and it's given twice. So in that way, you will be able to attend this talk and another one of your choosing. So in that case, please go back to the Expo lobby and join to the next session. Finally, this presentation is recorded and will be available on demand. Okay, so let's get started. So in the content of today's session, at first, we're going to start talking about 800 gig technology. So basically, we will answer the question when and how 800 gig technology will be implemented. So also, we're going to present the different testing scenarios and the different draft architecture for the first pluggables 800 gig. In the second part of the presentation, Francois will perform a light demo of a 400 gig transceiver. Okay, so here we go. Let's start with the 800 gig technical background. So at this point, two standard bodies are overlooking at beyond 400 gig rates. So in one hand, we had the Ethernet Technology Consortium, ETC, which basically has presented last year an architecture with 800 gig MAC, which is basically based on two 400 gig physical sublayers. And as you can notice, in terms of electrical lanes, we're going to see 8 lanes at 100 gig. So this architecture will be standardized in late 2022 or early 2023. On the other hand, there is a second body standard, which is the IEEE. So in this case, they are trying to overlook the 400 gig technology. So I present this slide that was introduced a couple of months ago. In there, they highlight that in today rate, it's only up to 400 gig. And basically, they are working in the development of 800 gig. Okay, so basically they have presented two different options. The first one is the 800 gig. Once again, 8 lanes at 100 gig. And basically they are forecasting that we're going to see this standard in 2 years from now, which is basically 2023. The second option is to have 4 lanes at 200 gig, but this architecture will take 4 years or more. Okay. So endorsing this forecast, there are other market reports available today. So this one, for instance, presenting the summary market for 400 gig and above transceivers in the period of 2020 to 2029. And basically, as you can see here, there is a very shy behavior in 2022. So the real business for 800 gig transceivers will start in 2023, but the real ramp up will start in 2024. A second market report coming from Light Counting present the annual sales in millions for the different transceiver rates. So in this case, they present all the rates going from 50 gig transceivers up to 800 gig transceivers. So once again, we start to surface the 800 gig at 2022, but the real ramp up starts at 2023. So here we are kind of answering the first question. We're going to see the standard samples probably at early 2023. Okay. So now let's talk about how to implement beyond 400 gig technology. So to get there, there are different technology items that should be fulfilled. So for sure, if we take a look at the current state of 400 gig samples, 400 gig technology, we're going to need more efficient components that for better management of the thermal issues and to reduce the power consumption. So the only way to overcome this technical drawback is by using photonic integrated circuits technology. So for sure, PEAK will be the base to develop 800 gig and beyond samples. In terms of coding and signals, as all the standards are forecasting today, the first generation of 800 gig transceivers will be 8 lanes at 100 gig, and it seems that PAM4 will be the chosen modulations. So in that case, we're gonna have 8 by 100 gig based on 53 gigabaud PAM4. So that's the key to arrive first at 800 gig. But finally, there is still a discussion on the table. So as I said before, the first generation will be based on PAM4, but there is also a new wave of transceivers based in coherent technology. So we don't know if even for future generation, we're going to see more coherent, basically in 60 QAM modulations. But well, this is still unclear. Okay, this is still under study. So I'm going to talk about the different draft architectures. And at this point, some transceiver vendors like Neophotonic are taking into account the architecture provided by the ITC consortium. And in this case, they are presenting the first draft for 800 gig transceivers. In that case, it's a PAM4 based transceiver, 53 gigabaud. QSF PDD is the form factor for this one. As I mentioned before, the key optoelectronic components inside of this transceiver will be based on silicon photonics and indium phosphide. So once again, we're gonna see 8 lanes at 100 gig PAM. Okay, so at this point, everything will be based on PAM4, and basically they will take advantage of this modulation because it's really mature in the industry, and it offers several benefits, such as it provides the double density of data compared to NRC, which enable to lower bandwidth components and material. So the idea is to reduce the number of fibers, the number of wavelengths compared to NRC. Okay, but not everything is perfect, and PAM4 it is not for sure. So PAM4 also brings to the table other challenges for design and testing. And basically, the real challenge is to analyze and debug a more complex system. Now we're going to have 4 levels instead of only 2 electrical levels that we used to have in NRC technology. So because of that, the signal to noise ratio is divided by 3 compared to NRC, and this is why PAM4 is more susceptible to noise. Other disadvantage is that PAM4 based transceivers are typically they present higher power consumption than the older generations. So at this point, to develop 800 gig, we're gonna need a tester capable to provide 8 lanes at 100 gig. And in Expo, we are proud to introduce to the market the new BA4000. This is an electrical bit error rate tester, which capable to develop the 800 gig technology. So as you can see, the entire BA family is composed by 6 different models. We have the top of the line enabled 800 gig testing, and basically uh, in this bit rate tester, we also provide all the analytical tools to debug and start the development of this new rate. So basically, it features prefetch and postfetch capabilities. Also, there are different monitoring tools, such as the bit rate over the time, and a very flexible GUI for error injection. So Francois Marcotte will show how this instrument works in a real scenario. So the bit analyzer is part of the EXFO unique end-to-end transceiver qualification solution. So as you can see here, for qualifying a transceiver, in EXFO, we have the capability to test the bit error rate with on-frame electrical lanes, with the bit analyzer, BA4000, or with the module analyzer, MA4000, or also we can have the protocol bit error rate tester using the FTVX 88460 module. For the optical side of the transceiver, EXFO has an extended expertise, providing all the different equipment needed to analyze the optical signal. So the optical offer is composed by different kind of switches, an optical sampling scope for eye diagram analysis, variable reflector for transmitter reflectance test. We also have different VOAs and power meters for the characterization of the receiver sensitivity. And finally, a complete line of optical spectrum analyzers for side mode suppression ratio measurement and wavelength verification. So now it's time to jump to the second section of this presentation, which is the live demo. So, Francois, the floor is all yours.
Okay, thank you very much, Aldo. So this is the test setup. As you can see here on the right, we have a BA4000, which is testing. Unfortunately, the evaluation board is not a 800 gig, it's a 400 gig. I'll show you how to test the 800 gig with the GUI. It's a simple thing. So, of course, if you have an evaluation board at 800 gig that you want to try, then we'll be more than happy to help you with this, as well as if you have a new network element card that's at 800 gigs. So that's where we are selling at the moment this product for those specific ones. So customer evaluation board is quite popular at the moment for 800 gig. So I have a software running on my remote PC connecting to the BA4000. The BA4000 has electrical lanes to the evaluation board, and I have a 400 gig transceiver loop on itself. So let me jump to the GUI. Here we go. So as you can understand, I'll stop here the test. As you can understand here, we have here the selection of 56 gigabaud. So if you have two symbols, obviously that's 100 gigabit per second per lane. And that's what you would be interested when you're testing your 800 gig design. So that means you would be selecting the 56 gigabaud, and then automatically these channels will be then adapted to 56 gigabaud. In the case here, in my example, I'm showing you the 26 gigabaud, but it will be exactly the same process for 56 gigabaud. So what you have here is you can control every channel individually by simply clicking on one of these box. So let's say channel 1, I click on it. You can decide to work on all channels at once, right? And then you can decide on the test pattern. So you can select the test pattern 31Q, 23Q, 16, etc. You can even use user define. You have equalization taps, so amplitude, precursor, postcursor, upper eye, lower eye. I'll touch this a little bit more on the PowerPoint after I get into this analysis. You have also CTLE on the receiver side, and you can play with the sensitivity. Now because I'm not on PPG, sorry. So on the PPG, then you can click on a specific channel and of course then change the parameter of individual channels. For example, if you don't want to have the same pattern for channel 1 versus channel 2, that's simply done like this. Everything I'm showing can be controlled via an API command. So meaning that it can be set into a scripting automation process. Okay. I'll start the tests. Before I go there, there's the clock, of course. You can always set up the clock by, if you want to use, let's say, an external scope and you want to send a special a clock to it, or if you have a clock data recovery like we do at Expo, then you can use that as well. So I'm running the test. So automatically it jumps into the bit rate area where you can see the bit rate for every channel. Now, the goal, of course, is to stress this. So you can decide to have error injection. So you can decide to have error injection on single ones. For example, you can decide to have a most significant bit or least significant bit selection. That's quite interesting. So you can decide to disable the one you don't want to use or the one you want to use. You can decide to have a single packet burst or burst packets. So burst, as we know, is the one that will impact the most the effect margin. So that is a test we are always recommending. So you can put the amount of packets that will be part of this and simply inject the errors. So here I'm injecting the errors on channel number 2. You can see already an impact on that channel. It's like an indicator that there are some errors happening. So visually, without going anywhere, you can see that something is happening on this channel, but I'll show you a little bit more after. If you decide to have errors on all the channels, then you select all channels, and then you inject the same type of errors on all the channels. Okay. Of course, you have all these measurements. You can look here at the bit error rate results. You can toggle it. You can pin it to the screen and then have it always on these results. Okay, and you can play, of course, with these different parameters. So the screen is pretty much configurable. And again, with automation, you can decide to have what you need. On the monitor side, we are monitoring, and I'll zoom this a little bit here. Come here. Oh, I'll start the runtime. Yeah, that's fine. Oop, wrong way. This is monitoring the bit rate over time per channels. That's pretty cool. So you can decide to have, information on all of them. So if I'm injecting, so you see, you don't have to change window to inject an alarm or I mean an error. So you can inject that on specific channel and then get the time error for every one of them. So let me increase a little bit zoom on these and move it around like this. So that's quite interesting when you want to monitor bit error rate per channel. You can see the full histogram over time. Let's say you want to do a 24-hour burning with temperature chamber on your 800 gig circuit or on your 800 gig transceivers. Then it's quite interesting to see what is the impact on every channel. The other point is the FEC. Of course, FEC is really important. Let me reset it because I did inject some errors. So here we see the effect distribution. So you have here symbol with errors. So that's the number of symbol that has errors. And here, how many code word count you have per symbol, right? So the goal is to have the best margin. Let me switch back to the PowerPoint quickly. Oh yeah, that's right. I gotta go not here, but here. So symbol error distribution versus FEC, as you can understand, after 15 symbol error, you're starting to have the FEC which is becoming uncorrectable. So you can see the FEC margin. Within the test set, we are evaluating how much in percent of FEC margins you have. Of course, the bigger FEC margin, the better, right? But eventually you'll get trouble and you'll have a smaller, of course, FEC system. And this is, of course, helping you to evaluate your design or your transceiver. So you can, of course, then see if there's any thermal issues, power instability, or signal interference difference on each port, for example. Now I'll come now to channel simulation. Let me go back here. If so, you can see the impact of errors on, of course, the margin, on FEC error margin, by simply injecting errors again. So if I'm injecting on channel 7, again, some errors, and on all the channels, then you're starting to see, uncorrectable FEC errors and correctable FEC errors. That's exactly what you want to evaluate over time if this is happening with your design. The channel simulation is a very interesting one as well. This is the signal that provides you the information on ISI, and you can see, of course, if it's good or not. Now you can play with the pre-equalization to increase or improve the signal. So I'll go just as a forward. Oops, sorry, again. I'll go here, minimize this. So you can understand that this channel simulation is quite cool because it shows you all change you're doing on the transmitter taps. You will then correct your distortion on your ISI. Of course, the goal is to have a minor tail, we say, right? So to reduce the tail harmonics. So that way you have a better quality signal. And the purpose of this is, of course, tuning. By tuning, and you can do that by using, of course, the BA4000, is you can tune the different levels and then improve the effect margin and, of course, your ISI. You can also use a sampling scope that will show you at the same time, of course, TDECQ and of course, the eye opening. And that is very important measurement as well. So altogether, like Aldo was saying, we have a very complete solution to evaluate your 800 gig transceiver or solution or design. I'm going back here to the test set. So I know I was pretty fast, but this is very versatile. And again, you can export these data. You can see the FEC results at the bottom. You can tag it to the system, and you can here have everything together and decide on the next steps you want to achieve. You want to add anything, Aldo, at this stage?
No, that's it. Probably we can jump to the question if
Yep.
there are any question from the audience. Go back to the presentation, please.
Yes, no problem.
So probably we can take one or two questions. I don't know if someone has a question in the audience. So is there any attendee?
I have a question, although this is Russ.
Hi, Ross. Yeah,
hi, how
please
are
go
you?
ahead.
Hey, are there any 800 gig transceivers available today, like pre-beta or?
Yes, well, as we said earlier in this presentation, there are several vendors working in 800 gig transceivers today, but well, probably we're going to start to see some alpha samples in late 2021, probably in early 2022, but the real commercial samples will be available in 2022 or 2023, okay? Not before of that.
And
For
if
sure.
I can add a point to this question is, at the moment, we're selling the 800 gig for design. So, for example, company are buying this to evaluate their evaluation board to build that 88 gig transceivers. So that's important.
That's you're talking about the electrical bird.
That's right, exactly.
Yeah.
Yes. So to be able to evaluate the new design, the new network element card that will be supporting 800 gig circuitry. Yes.
Have you heard of any plans for 800 gig coherent testing?
I'll let you answer, Aldo.
Yes, absolutely. This is something that Expo is overlooking today. We are trying to find a way to test on the electrical side, but also in the optical one. Okay, so keep tuned to have more info in the coming weeks.
Okay, thank you.
Yeah, sure. Well, So, well, that's it for our presentation. But before to finish the session, I would like to invite you to the session on next week. I will be talking about 5G transceiver testing with Jürgen Rommelsberger, one of the application engineers in EMEA, and also Francois Marcotte will be presenting a different in-depth session. The subject is timing and synchronization critical for 5G. So you will be more than welcome. Okay. So thank you so much. That's it for this session.
Thank you.
Thank you, Francois.